Hello, welcome to IMUCET class for mathematics. So today's this video's topic will be limits, continuity, if probably will cover differentiability. Okay, okay, let's start. Okay, first of all, what is limits? So we will define limits, then use this idea to check whether a function is a continuity or not, and use these two information to find whether a given function is differentiability or not. Let's do that. Okay. I'm not going in a rigorous way. So I just tell the idea of the limits, then we'll move to continuity, and then the same as idea of the continuity, then I will go move into differentiability. There we do some rigorous work. Okay. So limit. Suppose I have a function, say f of x equal to say x squared. Okay. Here limit, say I want to check what happened to x equal to 0. That is, this is my domain. So is x squared, right? This will be my codomain. I want to check what happened to my curve at x equal to 0. I'm not checking exactly at x equal to 0. I'm just curious what happened to if I approach my points to 0, what happened to my f of x. So here limit f of x. Obviously, we know that at x equal to 0, it goes to 0. Whether it is a left hand side or right hand side, at x equal to 0, it is 0. Maybe say this may be easy. Let's do another example. Consider a function. So whenever my x is less than 0, the function is say plus 2. Whenever my function is positive, say x greater than or equal to 0, my function value will be 1. I can write this as a say f of x equals, when x is less than 0, I can always get 2. When x is greater than 0, I can always get 1. Okay. Now, for this function, I want to check limit. So I'll go next page. So this function, I want to check what is the limit. Okay. So limit x goes to 0 f of x. Right? Now, come to this. So if I check at x equal to 0, this side, left side, that is x less than 0, it all the points are goes to 2. Right? Now, if right hand side, if I check my x is right hand side, I'm tracing the points, all the points go to 1. But x equal to 0, the point is 1. So how will I write? So if I say limit f of x, say left hand side. Left hand side I mark as a 0 minus. And I will say right hand side as a 0 plus. So here my f of x stays as a plus 2. So here my point is 2. At 0, say I will say limit f of x at x equal to 0. The function value will be 2. So sorry, this is 1. This is also 1. So these two are not equal. So I can say limit does not x is at 0. So again, I'm telling C. So left hand side, I'm tracing. I'm finding where if my x goes to 0, what happened to my f of x? In left hand side, if my x goes to 0, my function value goes to 2. Now again, my right hand side, if my x goes to 0, my right hand side, it goes to 1. So both are not equal. If these two are equal, then I say limit x is. It doesn't mean limit does not exist. Okay. So the idea behind this, I want to find whether the function has breaks or not. For example, suppose I have a function. Suppose I have a function. This is one function. Say another function. Say this. And here I have some jump here. Okay. Now, if limit exists means, so it exists at all points, there is no break. That is, I can draw my curve without take out of my hand, my pen. That is continuity. So here, let's check. I have to somewhere up my pencil and go here. Then again I draw, right? So limit is the tool where you can find a function is continuous or not. Here, if you check limit means if left hand side, it ends here. At right hand side, it ends here. Okay, they are not equal. So I can say this function is not continuous. Right? Okay, so the limit concept is a tool to check whether a function is a continuous or not. Now, what is continuity? So in a proper manner, so if function, I can draw a function without taking out of my hand, it's a continuous function, roughly. For +2 level, this is fine. So this is not a continuous. Because if I draw like this, then I can bring my hand to here, then I again draw. So this is continuous at x equal to 0. Discontinuous. Okay. So we will do some example. Then we'll move. I'll go next to page or I'll clean it. Okay. For example, say my f of x equals 2x plus 3, 2x minus 3. So if x less than 2, if x greater than 2. Now check. So less than 2, it has some straight line, the mx plus c in the form. So right hand side, it has some straight line. So straight line never breaks. So I don't need to check those points. The only point of curiosity will be what if x equal to 2. Let's check. So f of x limit x goes to 2 minus. I'm checking right and left hand side. That is, this is my 2 means I'm checking here. So here the function value will be, so limit x goes to 2 minus 2x plus 3. So this equals, so I'm going to substitute 2 here. So 4 plus 3, which is 7. Again, limit x goes to 2 plus my f of x, which is nothing but limit x goes to 2 plus 2x minus 3. So that means 4 minus 3. That is 1. So these two are not equal. That means, so at x equal to 2, my function is not continuous. So we will work this in a graphical way. Okay. Okay. So this is 2. So 2x plus 3. So 2x plus 3. If x equal to 0, I will take 3. Okay, 1, 2, 3. So yeah. So take y equal to 2x plus 3. If x equal to 0, I get 3. If y equal to 0, I will get 2x equal to minus 3. X equal to minus 3 by 2. So yes, this is a minus 3 by 2. So this is my graph. So up to 2 it becomes 7. Now again y equal to 2x minus 2. So x equal to 0, y equal to minus 3. So this is a minus 3. And y equal to 0 means I'll get 2x equal to 3. So x equal to 3 by 2. So this is 2. Okay, this is my 3 by 2. So the graph will be, this is a straight line. So sorry. So up to 2, it becomes 1. So this is the gap, a jump. Okay. So my whole curve is from here and then here. Okay. So this is not continuous. Okay. Sorry. Maybe we have to check this side. So my graph will be like this. Okay. This is my jump. So from here to here, it goes here, then it's come down and go. Maybe I will remove this. This will be useful. Okay. So I have a jump. Doubt. Okay. So we want to check discontinuous points. You have two ways. One, you have to systematic, say absolute limit x equal to whatever the point are plus, and check limit x equal to minus a minus. If they're equal to a function value, then it is continuous. Okay. Or roughly you will do a graphical method. Okay. Now we do one more problem, kind of trickier problem. So the important result will be, so limit x goes to 0, sin x by x is equal to 1. Okay. So limit x goes to 0, sin x by x is 1. So always remember this. You always expect a one problem from this kind of method. Okay. So we will do problems in a problem solving section. So, okay. What is the intuition of limit? So its application will be in continuity. So whether to check a function is continuous or not. What is the intuition of limit? The idea of limit will be roughly, so we have two functions, sin x and x. Which function moves faster? So limit roughly says that, suppose limit, say f of x by g of x. Okay, that means, okay. So if it is positive means my f of x is moves faster. If it is negative means my g of x goes faster to that particular point. Okay, but this is beyond our lecture. Anyway, just a points to ponder. Okay, so we'll move to continuity. We may do one more example. I want to use this result to do. Consider some difficult. Okay. F of x is say, x square sine 1 by x and 0. If x not equal to 0, if x equal to 0. So I'm going to use this result in some trickiest way. So, okay, I will write x square as a x into x, right? Or x into 1 divided by 1 by x, right? This is the idea. Now, the function value will be x into sine 1 by x divided by 1 by x. So I have this format, sin x by x, right? Now, if x goes to 0, this becomes 1 and this becomes 0. So 0 into 1 is 0. Okay, so the function value will be 0. So limit exists, right? So you always use this. Okay. So any doubt, guys? Or shall I do one more problem? Maybe I will do one more problem. Maybe, yeah. So consider the function. Maybe I will give some homework. Find whether the function mod x minus mod x minus 1. So this mod x, I want to define what is mod x. This mod x means it's a distance function. When x is less than 0, it is negative points of x. When x is positive, this is positive. That is, for x is negative, I have positive value. When x is positive, I have again positive value. Okay, so this is a somewhat important function. So remember that. So we will stop here, limit and continuity. In next video, we will do differentiability. Thank you.